Hello students, in this week's video, we'll be solving some problem sums that involve us having to find stationary value or stationary points. So do get ready a pen and some papers and practice along with me. Let's look at some important concepts. Supposing you're given y equals to f of x and you're told that y has a stationary value or stationary point, so what does it mean? I'm going to use a diagram to illustrate it. Supposing if you have a curve that kind of goes this way, and if you notice that at this point here, right, if you were to draw a tangent line, right, so this tangent line is actually a horizontal line. And what is the gradient of the horizontal line? Yes, the gradient of that horizontal line will be equals to 0. So let's look at another point. If you will see that there's another point here, that we can draw a tangent line. A tangent line is a line that cuts only the point at, cuts the curve only at one point, and that tangent line, you can see it's the horizontal line, and that is when the gradient of horizontal line is equals to 0. Right, so why is it called the stationary point? Because if you were to trace the curve, you imagine you are somewhere here and then you travel all the way up here. When you reach the highest point, basically you will just like stop there for a while before you proceed further down. So you can actually compare this with riding on the roller coaster, right? When you ride to the highest point, you stop for a while before all the screams come in. So all these points that you paused are called stationary points. And that is when you can draw a tangent line which is horizontal to the x-axis. And that is when your dy dx is equals to 0. Let's look at what are the different types of stationary points. The point could be a maximum point, as what I've illustrated in the earlier slide. It can be a minimum point. It can also be something called points of inflection. So how does point of inflection looks like? So why is it called a point of inflection? Right, let's examine this curve here. Right, if you were to consider this part of the curve, point C is considered a maximum point, right, for this part of the curve. However, if we were to examine the other part of the curve, then that particular point here is no longer a maximum point, it's a minimum point. So when you have points like it's maximum for some part of the curve and minimum for another part of the curve, we call this a point of inflection. So it is possible for a curve to have a few stationary points. Right, and then so it's our job next to find out, to determine all the stationary points, when we let dy dx equals to 0, all the stationary points that we have got, what are their nature? Are they a maximum point, a minimum point, or a point of inflection? So the next slide, we will learn how to determine the nature of all these stationary points that we have found. So in this slide, we're going to learn how to determine the nature of the stationary point. So there are two ways of determining the nature of the stationary point. We can use the first derivative or the second derivative. So in this slide, I'm going to show you how we can actually use the first derivative to determine the nature of the stationary point. So supposing I have, after using dy dx equals to 0, and I found the values of x to be equals to 1. Right, so I have a point x equals to 1. But I'm not too sure that point, is it a maximum or minimum point? So what I'm going to do next is okay, x equals to 1, we all understand, we get it by using dy dx equals to 0. So the gradient is a horizontal line, right? The gradient of that tangent line, it's a horizontal line. So what we're going to do next is that if I can determine how the gradient of a point that is on the left side of x equals to 1, if I can determine how the gradient is like, supposing the gradient is a positive one, and then if I can determine another point that's to the right of x equals to 1, determine the gradient, and if I were to find that the particular point, the gradient is negative, and if you join all these three gradient ups, you can see that what you're getting is a maximum point. Right, so this is what we're going to do. All right, we're going to examine the gradient of a point that is to the left of x equals to 1 and is to the and the right equals to x equals to 1. So this particular point cannot be too far away from x equals to 1. It cannot be too far, because if it's too far, then it's not accurate. So what we're going to use is just going to use take x equals to 1 plus minus 0.1. That means on the left, you just take 1 minus 0.1. And on the right, you just take 1 plus 0.1. So we're going to use the 0.1 as a guide to find these two important points. To find the gradient of these two important points. So this is what we're going to do. All right, so 1 minus 0.1 to give us x equals 0.9. And you're going to substitute x equals 0.9 into your dy over dx, whichever gradient functions that you have found, okay, after differentiating your y. And if you happen to get the value to be negative, means you're getting a negative gradient, right? Negative gradient. And how do you draw a line with negative gradient? Yes, you will look in this direction. And of course, x equals to 0.1 will give us our gradient equals to 0. That's the horizontal line. And then we're going to take 1 plus 0.1. And if you substitute into your gradient functions, if you get a positive value, this is how your tangent line will look like. And if you join all these three tangent lines, you will form a minimum point. Okay, so this is how you use the first derivative to determine whether the point is a minimum or a maximum. Let's look at how the maximum looks like. So we use a similar concept. Okay, use a similar concept. We let x equals to 0.9, and if you find out that the gradient functions, whatever dy dx you have, it's a positive value, this is how your tangent line will look like. And of course, the x equals to 1, that is where you get your dy dx equals to 0, horizontal line. Okay, and then if you join them up, you will get a maximum point. Right, so this dy dx I'm talking about for the first and second case, of course, is different value lah. That's one. This dy dx is different from, I'm just giving you how you can go about finding it. Of course, there are different dy dx. That's why in the first case, you can get less than 0. Second case, you get more than 0. Okay. It can also be points of inflection, like what I mentioned earlier on. So how do you get points of inflection? That is when the point on the left gives you a positive gradient, the point on the right also gives you a positive gradient. And if you join all these three together, you get a point of inflection. You basically get how something like this. Okay, right. It can also be both of them are negative on the left and on the right, and it will look the curve. If we were to join them, right. So in this slide, we're going to use the second derivative to determine the nature of the stationary point. So what does second derivative means? Basically, you just differentiate your dy dx. That means you differentiate y 2 times. So supposing given the stationary point at x equals to a can be any constant. And if you're given a function y equals to f of x, and you have a stationary point at x equals to a, right? So you just differentiate the dy dx again to get your d squared y over the x squared. And if that value come up to be less than 0, then p is the maximum point. And if that value come up to be positive, then p is the minimum point. But there's a catch here. What is the catch? If the value come out to be d squared y over the x squared equals to 0, it is inconclusive, which means you cannot use this method to determine the nature of a stationary point. So you have to fall back to using the first derivative. So this is the catch. So this is something you have to remember. All right, so I haven't gone through all the concepts needed, right, to solve problem sums involving stationary values, stationary points. So we're going to do some questions from exercise 14.1. And are you ready? Right, let's look at question 4. So for question 4, we are given the curve y equals to 5x power of 6 plus 1. And this particular curve has a stationary point. For part I, we asked to find dy dx because it's from dy dx equals to 0 to get your stationary point. That is for part 2. Part 3, we asked to consider the sign of dy dx and to determine the nature of a stationary point. So basically, considering the sign of dy dx refer to the first derivative. Okay. All right, so let's look at part I, which is relatively easy. You just differentiate x to the power of 6, you get 6x to the power of 5. So 5 times 6 gives you 30. So you end up getting 30x to the power of 5. Differentiate 1, you get 0. So part I is easy. Part 2, we let dy dx equals to 0. That's how we find your stationary value, a stationary point. And from there, you find x equals to 0. But that's not the answer because the questions require you to find the coordinates of the stationary point. So when you say find the coordinates of the stationary point, it also refers to the y coordinate, not just the x coordinate. So you need to substitute x equals to 0 into your curve to get y equals to 1. And again, that is not how you present your answer because you were asked to find the coordinates of the stationary point, so you have to represent it using point form. So if you just put x equals to 0, y equals to 1, you're not going to get the final mark. So the correct way of presentation will be the stationary point, it's bracket 0, 1, close bracket. Okay, bear in mind the presentation is important, answering to the question asked. So for part 3, we're going to draw the table using the first derivative to find the nature of a stationary point. Right, so x equals to 0, equal to minus 0 minus 0.1, that gives you negative 0.1. So what we're going to do is going to substitute this value here into your dy dx. So your dy dx is 30x to the power of 5. So you're going to substitute x to be negative 0.1. And if you're going to use a calculator, you will see that this value comes up to be negative 0.0003, and that is a negative gradient. So for negative gradient, this is how your gradient line will look like in this direction here. Okay, and then x equals to 0, of course, this is where you get your dy dx equals to 0. Of course, this is where you get the tangent line to be horizontal line. and then you're going to substitute x equals to 0.1 into your dy dx. And you will get a positive value. Right, which is 0.0003. So the positive gradient would look like this. And if you join all these three tangents together, you will form a minimum point. So therefore, bracket 0,1 is the minimum point. So this is how you do question 4, which is quite straightforward. Right, let's look at question 12. So if you were to manage to stay through for the whole video, you'll realize that the concepts involving the basic concepts that we're working on this subtopic is just to find stationary point of value by letting dy dx equals to 0, and then use the first derivative or second derivative to determine the nature of the stationary point. The only difference is that sometimes the curve, the function is given to you, it varies. For example, the question 4, you're given quite straightforward one. For question 12, if you look at what you're given, it's slightly harder than what you get just now. All right. But if you look at what you're supposed to find, at part I, coordinate of stationary point, part 2, determine nature of stationary point, and of course sometimes you throw in the part 3 where you need to explain a little bit more, okay, like some concepts, involving the gradients of the curve. Why is it negative when x less than 0? So part 3 sometimes is considered a higher order kind of thinking questions. Part I and 2 are just basic, okay, just basic. So if you look at your equations of the curve, some of you may jump in quickly to use the quotient rule. I would advise you not to. Okay, if you're very good with the quotient product rule, of course you can just go ahead. But if you're not, then maybe it's worthwhile trying to simplify it first. And if you can always use the power rule or the chain rule, just go ahead. Okay, right. And in this case here, yes, we can simplify it further by splitting it into two fractions to get x squared plus 54 over x. And why do I change the 54 over x into 54x to the power negative 1? Because I need to apply the power rule. So I need to change this to the negative index to apply the power rule. And if I've forgotten how to do this, how to change from positive index to negative, I'm just going to show it to you one more time here. It's good that you go and look at my earlier slides and do some quick revision. So I can actually write 54 over x as 54 over 1 times 1 over x. So 54 over 1 is just 54. And 1 over x is just x to the power negative 1. Okay, right. So we're going to find dy dx. Okay, right. So differentiate x squared, you get 2x. Differentiate 54x to the power negative 1, you get negative 54x to the power negative 2. The next step, we're going to change this back into positive index. Why is that so? Because we're going to let the dy dx equals to 0, so it's easier to work with positive index. Okay, so the next step is let it equals to 0. All right, and I'm going to multiply every term with x squared. Because of this denominator here, x squared, I want to get rid of your denominator x squared. So basically, I'm just going to multiply everything with x squared. And let's see what happens, okay? All right, so we get 2x cubed equals to 54, x cubed equals to 27, x equals to 3, and that's not the end yet because you have to find the coordinates of the stationary point. So we need to substitute x equals to 3 into your curve to find the y coordinate, and that's again not the end yet because you must always answer to the question asked. So therefore the coordinates of the stationary point will be 3, 27. Okay, that's for part I. Part 2, determine the nature of a stationary point. Here you're not asked to find which method. You're not specifically asked to use the first derivative. So usually the easier way is to use the second derivative. Okay, so basically you just differentiate your dy dx one more time. All right, differentiate 2x, you get 2. Differentiate this one here is just negative 54. You bring the negative 2 down, right? So negative 54 times negative 2 will gives you 108. Negative 2 minus 1 gives you negative 3. So we're going to substitute x equals to 3 here. So when x is equals to 3, let's see what happened. All right, you get the value for the y, the squared y over the x squared to be 6, which is the positive value. So therefore, your 3,27 is a minimum point. Okay, more than 0 is minimum. Right, so that's for part 2. All right, part 3, explain why the gradient of the curve is negative when x less than 0. So x less than 0 means x can be negative 2, negative 3, negative 4. So if x is less than 0, why is it your dy dx is a negative value? All right, so this is how we explained. So we need to use the functions for dy dx to explain. All right, so if we were to look at your dy dx, you look at this one here, we're going to zero into this. Your x squared is more than 0, right? Your x, of course, cannot be 0 lah, because 54 divided by 0, it's undefined. So x squared is more than 0. Then, of course, 54 over x squared, if it's 54 is positive, so positive divided by positive will be positive. And if you're going to multiply by negative throughout, then of course negative 54 over x will become a negative value, right? And since x is less than 0, so 2x will also be negative. So you have negative minus negative, so that makes your dy dx negative also. Okay, so this is how you explain part 3. All right, let's look at question 7. You see that question 7 is slightly different from the past 2 questions. Because for question 7, you're given the stationary point. And then you're given 2 unknowns in the curve, all right, A and B. So you asked to find the values of A and B. So the basic concept here remains the same. What's the basic concept? Means to find stationary point, you basically just let dy dx equals to 0. Right, so the first thing is just to find your dy dx, which you will get 6x squared minus 8x plus a. You differentiate b, b is a constant. Constant is just a number. You differentiate a number, you get 0. Alright, so you end up getting 6x squared minus 8x plus a. So for stationary point, you just let it equal to 0. And since you're given the stationary point is at x equals to 1, you can substitute x equals to 1 into your dy dx. And you will get a to be 2. Alright. And since you're told that this 1,5 is stationary point on the curve, it means that the point lies on the curve. It means that you can substitute x to be 1, y to be 5, a to be 2 to find the values of b, which is equals to 5. So that's part I. So for part 2, you asked to find the coordinates of the other stationary point. And to find stationary point, you just basically let dy dx equal to 0. So after finding the values of a, which is 2, you can just happily substitute inside here and then let your dy dx equal to 0. And then you can factorize 2 out first, or divide by 2 throughout, and then factorize your 3x squared minus 4x plus 1. And you can get x equals to 1/3 or x equals to 1. So x equals to 1 is the one that's already given here. Right, it's already given there. So we just need to worry about x equals to 1/3, because that is the other stationary point that we need to find. All right, so we're going to substitute x equals to 1/3 into our curve to find the values of y to be 5, 8 over 27. So therefore, the other stationary point will be 1/3, 5, 8 over 27. Right, so we have 2 stationary points now, 1, 5, and the other one is 1/3, 8 something, I don't know what. All right, so for these 2 stationary points, we need to determine the nature, which one is maximum, which is minimum. So because the question did not ask us specifically to use the first derivative, we just use the second derivative. Always use the second derivative. Okay, if it fails, then we use the first derivative. So you differentiate the dy dx one more time, you'll get 12x minus 8. So how do you present your answer? So you do it this way. You start off by, when x is 1/3, you sub x equals to 1/3 here to get this. and then you get -4, which is a negative value. So therefore 1/3, 58/27 is a maximum point. When your d2y, when your d squared y over the x squared, it's a negative value, is a maximum point. Then you go on to say when x is equals to 1, you find the values for the squared y over the x squared, and you get positive. So therefore, bracket 1, 5, it's a minimum point. So this is how you present your answer. And if you can do it this way, you're going to get full marks. Okay, so question 17, it's a very challenging question, right? It's challenging because basically it just involves a lot of explanation. And this explanations, you can only do it when you have a firm concept of what is going on. It's unlike the first few questions, you just like dy dx equals to 0, find stationary point, determine the nature of stationary point. Here you need to explain a little bit more. And here you will realize that it actually connects to your rate of change. Yes, so if you look at this graph that you're given, it's P represent the populations of some organism growing in a confined environment. Confined means an enclosed environment with some conditions, things like that. Okay, it's not open, it's enclosed. So for part I, you asked to determine in terms of the sign of dy dx and d squared y over the x squared. So of course here is not dy over the x. If you look at the graph you're given, here what they are referring to is your dp. This is not y, this is p, right? This is t, right? So it's dp over dt, and here they're referring to d squared p over dt squared. You just based on the graph that's given and using these two terminology, right, we need to describe how the rate of the population is increasing changes with time. So if you were to examine the curve, all right, you can see that this part, you can see that the organism is like, increasing. When your T increases, your L also increases, right? Right. So this is increases. This one is when it's at the steepest, because when you draw a tangent line, you see that this tangent line is at the steepest. So this is part where the population growth is at the maximum, and then it's slowly still increasing, but it kind of tail off really slower, increasing but at a decreasing rate really, and then finally tail off, reach a maximum point, and then stay there. Okay, so how do we describe it? All right, so your dp over dt represent the rate of change of populations p respect to time, and your d squared p over dt squared represent the rate of change of the dp over dt respect to time. Okay, so there are two parts of the curve as what we have mentioned earlier on. The two parts of the curve. Okay, never mind, cannot erase this part of the curve. Okay, doesn't matter. You just look at my explanation. So this part of the curve is okay, doesn't matter. Let me try one more time. I don't know why I can't highlight. Okay, all right. So this part of the curve, when your t is more than 0, less than t prime, your p, as well as we explained just now, is increasing. And if p is increasing, means your gradient function, your rate of change of gradient function, your rate of change also gradient function. The rate of change dp over dt is positive, so more than 0. And since your dp over dt is positive, it means your d squared p over dt squared is more than 0. And then if you look at the second part of the curve, where your t is equals to ti, okay, the particular part, this is where just now we mentioned, if you were to draw a tangent line there, that is at the steepest. So hence the population growth is the fastest there at t equals to ti. Then what happened when t is more than ti? Okay, so this is this is what is happening here. You see that the population is still increasing, but then it's at the decreasing rate. That means it's slowed down already, getting lesser and lesser. Not increasing, not getting lesser and less, not increasing as much as just now. All right, so therefore your rate of change of population is negative, decreasing. And since it's negative, therefore your d squared p over dt squared is less than 0. Okay, so this is how you explained, okay, in part I. And then in part 2, yes, so L shows the maximum population growth in a confined environment. That means it will just keep increasing until it just tail off, reach a certain maximum point and then stop there. It cannot go any further. That's what it means. All right, let's look at question 18. So for question 18, what they're trying to say is that if you are given a function, if you have a function y equals to something, and if you can find your first derivative dy over dx, and you can also find a value for your d squared y over dx squared. So what they're trying to say is that this value for your d squared y over dx squared can only have two possibilities. It's either less than 0 or more than 0. Only two possibilities. So do you think this statement is true or false? Do you agree with this statement? This is what they're trying to say. Do you agree with it? Okay, let me repeat. That means if you're given a function, and if you can differentiate the function, and if you can find the first derivative and the second derivative, the value for the second derivative can only be less than 0 or more than 0. That's what they're saying. So is it true? I don't think it's true. So if you don't think it's true, then you must give an example to show that it is not true. If you say that the statement is false, then you give an example. So this example I'm going to give is, supposing we have this curve y equals x to the power 4. You can give any other curve, not necessarily the same as mine. If you're going to differentiate it, so you see that I do have a function for dy dx, which is 4x cubed, right? And I can again differentiate it. Yeah, for maximum minimum point, yes, that's when I let dy dx equals to 0, right? I will get x equals to 0. And I can differentiate the dy dx again to get d squared y over the x squared equals to 12x squared, right? And if I'm going to differentiate x equals to 0, you see that I'm getting d squared y over the x squared equals to 0, which is not what is said in the question, that they can only be less than 0 or more than 0, because what I'm getting is actually equal to 0, which kind of contradict the statement, you know, the contradict the statement that they have said, right? So therefore, this statement is false. So if you want to explain, if you want to disagree with any statement, you just give an example. Once you can find an example, then the statement does not hold anymore. All right, so that's the end of the video for 14.1. I will do another video for 14.2.